to today's class is Math with Joy. So today we're going to be looking at application of integration. Now I want to believe that you've seen our video on integration and I hope you liked it, you shared it, you commented and then you invited your friends. Please, if you've not, please always do that. It's important you subscribe so as to get notification when our videos drop. Now, if you've seen that video, I think the next question should be, what is this integration actually used for? So it's important you know why you're learning what you're learning. Now, this integration, there are some calculations. Today, I'm going to show you how integration helps us do these calculations easily. For instance, finding certain areas, volumes, and all that, that the normal formulas or ordinary formulas may not help you to do. So how does integration help us to get to that? So I'm going to be grouping this application into three: area under curve, volume of solid of resolution, and then application to kinematics. So let me explain the last one first, and then after the last one, I'll go back to the first one. Now, when we talk about this application to kinematics, if you're a physics student, could you please draw close? Now, excuse me, if you are given displacement and you are asked to find velocity, what do? You differentiate displacement with respect to time, and then you get velocity, right? Okay. And then if you're given velocity and you are asked to find acceleration, what do? You also differentiate velocity with respect to time, and then you have what? Acceleration. That means if you are given displacement and you're asked to find acceleration, that means you find the second derivative of displacement, right? That's differentiate the first time, then differentiate the second time. Is that correct? Beautiful. So now from this analogy, you will see that in this, to find the next derivative, we're moving forward. All right. Now, what happens if I want to take you back? What do I mean? What I mean is, in a question, you are given acceleration, that the acceleration is something, something, something meter per second squared, and then the question says find velocity. What happens? In this case, you are not moving forward, you are moving backward. Now, integration helps you do that because integration means what gave you this acceleration in the first place? That was velocity, right? Now, if velocity gave you acceleration, and now I have acceleration, I want you to go back to velocity. So in our video in integration, we saw the connection between differentiation and integration. So I'm not going to go into that. So if you've not seen it, please do well to see that to help you to understand this video better. Now, that is actually the application to kinematics. All right, now, so moving forward, we're going to be looking at area under curve. Area under curve. And for O level, let me just categorize this area under curve into two. What's the first one? The first one is area bounded by the curve and the x-axis. Case, you will discover that it is above the x-axis, right? So what do? We simply integrate as limit tends to from a to b of f of x with respect to x, as simple as ABC. Okay, so now for the second one, what's the difference? The difference is that we'll have minus the integral because it is below the what? The x-axis. Then for this one, it is still the same minus. I hope you understand the interpretation. Okay, so now the difference is I don't know the limit. So I can have maybe minus 2 to 0. I can have 5 to, but just know that A is always the lower limit. Okay, so you cannot have your range from higher to lower. You can't have 5 to minus 1. It is wrong. Okay, so you see that on the number line, as you can see on this x-axis, your A, if on the positive side, is always very close to 0, or it is on the negative. So you can't have from upper limit, this is one careless thing that students always do, not being careful with their limits. You see someone doing the right thing, but then mixing up the limits. All right, having his or her range to be maybe from B to A instead of from A to B. And at the end of the day, you'll be getting probably a negative area. So take note that area cannot be negative. Whether you're working on integration or in anything, as far as mathematics is concerned, you know what area means, right? The space taken up by a 2D shape, So area cannot be negative. So imagine looking at area that this curve makes with the x-axis, that's the space, like that shaded region. How will it be negative? How can space be negative? It's not possible. Okay, so most times when you get that negative area is because, aside making mistakes in your calculations, is mixing up your limits, having your range from higher to lower instead of lower to higher. Now, still under this area, still under area bounded by the curve and the x-axis. This is just the case of a what? A parabola. All right, now what if we have a trinomial function? This trinomial function can look two ways. So let's see. So either we have it go up, come down, or we have it go down, up. So whichever way, this is still the area. So now what happens? As you can see, this curve touches the x-axis at 3 points, and that is because the power of x is 3. So since the power of x is 3, it means we'll have 3 values for x. So instead of just a and b, we'll have a, we'll have b here, and then we'll have c here. Up first, so we'll have the integral, so our limit lower to upper, f of x, right, with respect to s, of course, minus y, because in the second bounding, it's bounded with the x-axis below the x-axis. So we'll have minus the integral, then the limit at which it is bounded is b to c. So we have b to c, f of x dx. So for this other case, now we have the area, we have the bounding below first. So we'll have minus the integral with our limit a to b, f of x dx, plus the integral with limit b to c, f of x dx. Now let me ask you this question that your mind might be telling you. All right. So now, what difference does this make? The first one positive, minus. What if I do the second one plus then minus? My darling, it is the same function, yes. So what is the big fuse? The big fuse is that the limits are not the same. Are you getting me? Now, when this curve bounds with the x-axis above, you have limit a to b. When it bounds with the x-axis below, you have limit b to c. They are not the same. So don't say because the function is the same, why can't I just do integral f of x dx with limit a to b minus the same thing I did for in case A. Why can't I just do it in case B? My darling, if you try it, you might end up getting a negative area. Even if you have a positive area, you'll get the wrong result. Okay, so you see, why is this important that you understand these interpretations? Whenever you have a question that has to do with area under curve, my darling, whether you are asked to sketch the curve or not, it is important that you do your rough sketch. Now, why is it important? You see, if I don't sketch this, how will I know that I should, the limit a to b has to be positive first, then minus. Are you getting what I'm saying? So how do I know what to do? Because when you are adding, when you should be subtracting, no matter how beautiful your work is, you have done, in fact, you make a mess of the whole thing. Okay, so that is why you need to understand this pattern, how it goes. All right. So in conclusion, as you get ready for WAEC, whether you're writing WAEC, NICO or whatever, it is important when you see a question that has to do with area under curve, please do well to do what? Do your rough sketch before you calculate the area. So with this, you have a clue as to how the pattern, whether I should have positive, negative, or negative, positive, or positive, positive, or whichever one. It is from the movement of the what? Of your curve. Okay. So now having said that, remember I said we're going to be looking at this in two ways. So this area under curve is actually a property of what? A definite integral. You will discover that this is actually definite integral, which was why I didn't bother to talk much about definite integral in the first video. Okay, because when you talk about application, area under curve, you of course you have your limits. Without limits, you can't find the area. Okay, now the second case, the second part, look at area bounded. Okay, area bounded by two curves. So let's focus on a curve and a straight line for your O level. So these are just the two cases we're going to be looking at. So in that case, I have a curve and then I have a straight line. There are two cases to this as well. And then let's say I have my curve going this way, and then I have a straight line going this way. Now, what's the difference between these two? Let me show you. So this is the area bounded. We're no longer focusing on the area. Look at the area bounded by the curve and the x-axis, but that's not our interest. Our interest now is the area bounded by the curve and this straight line, which is this shaded part. All right. So, okay, so we still have y to be equal to f of x. So this is case one. And then for case B, we also have y to be equal to f of x. So what's the difference between these two? Now, the difference between these two is that in case A, the line is above the curve, right? So when you are integrating, it will now be the function of the straight line minus the function of the curve because the straight line is above. Then in case 2, the curve is above the straight line. So it will be integral of the curve minus the straight line. Okay, so the one that is above, it is the one that is above minus the one that is below. I don't know if it's making sense. Okay, now the question now is, where is my A? Where is my B? Since I am not looking at area bounded by the curve and the x-axis. Now the point of intersection between the curve and the straight line, this is my A. That is the value of x at that point anyway. Okay, because everything we are doing is with respect to x. So for this one, if you trace, look at the intersection. If you trace it to the x-axis, this is my B. So the same thing happens here. Trace it to the x-axis, you have your A. Trace it to the x-axis, you have your B. Okay. So now the two curves enclosed in this area becomes, so since I have a straight line, that means the first, for the straight line I have this, and then for the curve, for the straight line I have y is equal to x, and then for the curve I have y is equal to x squared. Now the difference is this. Okay, so now if I have, we looked at area under curve, we've seen what it looks like. So now that area, the part, the shaded region, if I rotate it on the x-axis, I will have something like this. Okay, so now rotating it on the x-axis, I'll have the volume to be the integral a to b of pi y squared dx. So if I also rotate the same curve, the same region on the y-axis, I'll have something that looks like a bow with the volume being equal to the integral, our limit will be a to b of pi x squared dy. Now, the difference between these two is this: for someone who will be asking, how will I know which is which? If I have a question, how will I know whether I should use the first or the second? Now, how you will know is this: if you look at the first case, the rotation is on the x-axis, all right? So we have our AB on the x-axis. So in the second case, the rotation is on the y-axis. So we have our limits on the y-axis, and that's why it is with respect to y. Okay, another question you'll be asking: how can I integrate x squared with respect to y? But hold on, we'll look at a question and you will understand how that is going to happen. Okay, all right, now we're going to look at a question, and with that question, we'll a standard question that will cover both area and volume. Come with me.